Good evening, everyone. Welcome to another JavaScript in London. Obviously, tonight I am joined by Pawel. Pawel has done one of these previously, and he's here to do another one again. This time, something a little bit more hands-on, which I think will be good. It's not something we've done previously ourselves, but yeah, we've had a variety of different talks recently. So nice to have something a bit more interactive. So hope you're all keeping well anyway. Yeah, been a little while since I've done one of these. We had one last week. My colleague Jack hosted that one. But yeah, hope you enjoy this one. And without any further ado, I will pass you over to Pawel. Hi, Pawel, can't hear you there.
Sorry, I was muted. Can you hear me now?
Yes, all good.
Yeah. Yeah, sorry. Yeah, so I just was saying that I think is going to be quite interesting to me because it's a kind of crazy idea that came to me to not only make a workshop on monads, but also make it in Zoom and online. And I did a bit of, I tried it out and it came quite well with in a small experimental environment. I've done it. So yeah, so forgive me if there's still a small glitches. This is the first time I'm doing this in kind of larger group. But yeah, I think it's a cool experiment, and I know if it works, I'd really be very excited. I'll be very excited. Yeah, so the topic of the sort of theme of the workshop is write your own monad in 15 minutes. It's a little about me. My name is Pawel Badenski. I'm a CTO at PricingMonkey. And shameful plug, we're looking for talented programmers. We're a small technology startup in fintech space. We have a software as a service product. We're a passionate group of people with an average of 15 years of experience in the industry, and we're basically solving difficult problems for our customers. There's three parts to the workshop. So the workshop is called Write a Monad. I will teach you to write a monad in 15 minutes. And it's a bit of a spin. So give me 1 second, let me just, yeah, that was my phone. It's a bit of a spin. So yeah, you will write a monad in roughly 15 minutes. And then we will extend it to be something slightly more practical. And then that should be another 15 minutes. And then I'll leave time for a Q&A, which would be, however long we need, hopefully around 10-15 minutes. So each part should be around 15 minutes long. So before we begin, let's test the Zoom messaging. You should be able to send messages to me and to me only. That's going to be kind of important during the workshop. So if you could just let's take 1 minute now and send me a private message and just tell me what do you expect from this workshop and what puzzles you about monads, what you would like to have answered, or just send me a hello so that we know that it's working. So I'll just give you 1 minute from now. That's my timer. All right, thank you for your messages. So this would be actually super. These were actually super useful messages because it reminded me about the 2 points I wanted to mention. Is one is a bit about how I got to do this workshop. I actually wanted to learn monads for people who haven't read the intro on meetup.com or on LinkedIn. I actually wanted to learn monads for quite a while. I was always very scared of Haskell, and that would be the language people would mostly point you to for monads. And you have to then learn a language that kind of looks like Perl. And then there's Scala, and there's implementation in Scala was kind of difficult as well. And JavaScript is really the first time when I got to really use monads, and I really got to see implementation of the monads, and I discovered that they're not as scary as you think. And there's a lot of weird language going on when you use monads. It's functors, monads, applicatives, semigroups, and they're not as scary as you might think. And that's kind of what I want to show you in this workshop. I want to show you that monads are not as scary as you think, and actually quite much simpler than most people expect, than I expected. And the second point I wanted to mention about this, the format of this workshop, is that we're going to sort of do it in a sort of reverse way. So I'll guide you through the implementation, and you'll implement the thing yourself. And then there's going to be time for questions and to see, okay, what is that? How is this useful? And so on and so forth. I hope that's going to be interesting to you. I hope that's going to be exciting to you as it was to my previous participants. Now let's get it rolling. How? So a few sort of technical details. Obviously, I can't hear you, so I'm just going to be kind of guiding you through these steps. We'll be using JSFiddle. I will send you I'll be sending you JSFiddle links that you'll use to develop the application, develop the to write the implementation. Each step there's going to be 4 steps. They start with a test, so you're going to have small tests that you'll have to make pass. So you're going to make sure that to provide implementation for that test. The steps are designed to be really small, so you should be able to finish each test in 2 to 4 minutes. And after each step, I will share an updated solution, and I will also share the next step with you. So just to recap, the flow is I share the step. I share a test with you on JSFiddle. You will get 2 to 5 minutes, 2 to 4 minutes, 2 to 5 minutes to write implementation. I will share the time left at around half through the steps. I will remind you that we're around half the time. If you're struggling, send me a private message, and I will try to send you a hint or guide you the right direction. And after time is up, I will share my implementation with you, and then we'll basically repeat the process for next small step. So this process is sort of influenced by TDD, test-driven development. The difference here is that in the implementation, I actually want you to try to write the, not to fake the answer, but actually try to write the answer that delivers on the solution. Yeah, that's that. So one thing I wanted to mention is, even if you don't get to write the correct implementation, even if you don't get some steps right or all of the steps right, it's not a problem. I think that's the process of learning. And a sort of short story, as a lot of us tried in these times, I tried to bake my first bread this weekend. and it actually failed. It wasn't quite good, but I learned a lot in this process. So it's kind of similar here. Is you know, even if you don't get everything right, you learn a lot in the process. Okay, so the first step would be the simplest monad. I will share a JSFiddle link on the chat in a second. In a second. You should now see a link, JSFiddle link on Zoom group chat. And I will also share that on my screen. So in case you don't see it, you can actually you could actually type it out. So all of you should also see that link. I will explain a little about JSFiddle interface. You have run and save buttons. So when you change something, when you write your implementation, you can either press Command S or Control S, depending on whether you're on Mac OS or Windows, or you can just click Save here, or you can click Run to execute and to see if your test is passing. And my test is not passing at the moment. It's red, but once you actually write the implementation, and you can write the implementation below just in this code, so you can just start writing here. And if you make the test pass, this HTML, this window on the right should become green. Okay, so let me know if you have any questions on the private chat, and I will start a timer now, and you will have 10 minutes to make this test pass. You have 1 more minute. Cool. 2 minutes is up. I will now give you the implementation, one of the implementations possible. There might be more than one. It might not be exactly the same as what you did. So I will say, okay, give me a variable called box, and it will be a function that takes a value as an argument and returns a value, an object with a property value set to the argument value. And if I save this, voila, it passes the test. Just as a hint for JavaScript, I could obviously, in the newer version of JavaScript, also write this. Just a bit of JavaScript trivia, and that would mean the same thing. Okay, I hope this was a good warm up for you, even if you haven't managed to get it working. I hope this basically provided you with the kind of warm up that you need for the next steps. So let me now write a next test that you will then be able to implement. So step 1 will be implementing a function. We'll call this function funky for now. So it's a funky function that takes a box, and the funky function also takes another function that increments a number by 1. So that funky function takes a box and an increment function, and it returns a box with an incremented value. So a funky function takes a box, a function that increments numbers, and it gives you back a box with incremented numbers. So box 3 incremented box 4. Okay, so now you will have, oh, sorry. And then let me share this. So you can either copy, I'll show you the link with you. This is the updated link with the new test. You can either copy this test from my link, or you can just use my JSFiddle link to write your implementation, whatever works better for you. And you will have 4 minutes for that. Oh, sorry. You have 2 more minutes. Okay, so time's up. So let me now provide the implementation. So my implementation for this, and your implementation might be different, is I have a method called funky, and I will take a box and a function, and then it will return a value with the new value. And the new value, so it will return a new box with the new value, and the new value will be a function. I will take the function that came to me as a second parameter, and then call it with the current value of the box. So let's make it super obvious. Current value is box value, and function of current value, and the step passes. Okay, so now this method is actually called map, commonly in the functional programming, and this in the monadic words. And the if you had a map implemented for a box, it would mean that we basically implemented a functor. So if you have a map implemented for an object, this makes this this means that you sort of build a functor. So the kind of difficult language, I'm going to be introducing this difficult language step by step, because there's a lot of really hermetic language, but it actually means simple things. So you just implemented a map which makes this box a functor. Okay, so let's get, so this is 30% done. We're only 2 steps away from our monad. So let's give another step. And one of you, Wasim, asked me to share the test case in chat. So I will also do that. I will paste a JSFiddle, and I will also paste a test case in chat so you can copy it. So step 2 will again going to have increment function, and we'll and we're going to have a function called funky. And again, it will take a box as a first argument. And now for a bit of a spin, it will take a function, but that function will be wrapped in a box. And we'll also expect the result to be a box with an incremented value inside. So this will be your second step. And I'm pasting the JSFiddle now. And I'm also going to paste the step 2 for you to copy. And you have 4 minutes for that. You're halfway through, 2 more minutes. Okay, so time's up. Now let me just show you my implementation of Funky. So one way to implement it, and there's actually quite a few ways of implementing this, so you may have done it nicer than me. I'll try to be kind of very explicit here. So we have a Funky, and Funky accepts a box and a boxed function. And again, we'll return a value with a new value. And how we'll build our new value is that we'll basically need to extract the function from a box first. So that's actually a function that we extracted from a box, from a second argument. And then it looks similar to map. So we'll apply that function to the value in the box. And if I run that, there you go, it passes. Now, this method is sometimes, it's actually called different names, but one way I'm familiar with is called AP. And, oh, sorry, refactoring glitch. There you go. Can I make it smaller? Yeah. And if at this point, because we have a map and an app implemented for our box, we have an applicative. So if you have a map implemented for an object, it makes it a functor. If you have, as we did, provided both map and AP, you have an applicative. So if you've ever seen this hermetic weird word applicative, that's all it means. So we're uncovering basically taking a little hermetics out of monads. Cool. So this is almost we're almost there. This only last step. We're only one last step away from implementing a monad. So let's get it going. So the last step will be we'll have another funky function which takes a box, and then something that looks a little more different, but actually don't be afraid of it. It's actually easier than you think. It's a function that takes a value and then returns a box with incremented value. Oh. So let's just maybe sorry, I'm just going to reorganize this a bit. Okay, and this would be the last step. You need to make this a monad. And this is your new JSFiddle link. And the last step. And I'll give you 3 minutes for this step. You have 1.5 more minutes. Okay, time's up. Now I will implement the last remaining step. So wondering how many of you managed to get this. This is actually easier than, this looks very scary, but it's actually, when you see the implementation, it's actually easier than you might think. So it's a box and a function returning a box, and all we need to do is take a function returning a box and then give it the extract the value from the box and return that. Done. So looks pretty scary, but it's actually quite easy once you see it. And the last funky function has many names again. but one way I'm familiar with it, or the one way it's known, is called flat map. And now, if a function, if you implement a flat map and a map and an AP and a map, let's actually change this over slightly. You get a monad. So hooray, you have just implemented your first monad. And in the meantime, I don't know how many of you have seen, but I drew a beautiful picture of a box for our problem. Yeah, so that's pretty much it. This is a simple implementation, kind of showing you the drill, how to implement a monad. It's not super useful, but we'll get to that. So we got a simplest monad and a few, so we have type hierarchy. You have this magic word functor. If you implemented a map for some object or some class, you have a functor. If you have two methods, map and AP, you have an applicative. And if you manage to implement all three, you get a monad. And that's all it is. That's the magic. It's as simple as that. And it's the thing with this type hierarchy, and I'm going to mention a little bit more later, possibly, maybe, is that it's kind of like HTTP interface. Hopefully most of you know it. In HTTP, you have get, post, delete, and put. So you can only 4 methods. So you have a thin interface, but actually you can do a lot with it. So in functional programming with monads, applicatives, you only have the simple interface. But actually you can do a lot with this interface once you start combining things together. So once you kind of get more familiar with this language. So just to give you a few tricks, I know some of you implemented that this way. You could actually implement AP using map. That's one trick. Or you can implement a flat map by introducing an extra method called flatten, which basically takes box packed in a box and flattens it. It's very similar to flattening the list. It's actually the same concept. And hence the name flat map, because it maps and then flattens. Okay. So there will be time for questions, but let's get to the second steps. So in the second step, I will show you how to turn your monad into something more practical. So we're actually going to implement a very useful monad in a functional word called option. Some people call it maybe monad. So let me take this code, and I'm going to make a few changes here. So it's not going to be a box anymore, but I will call this function sum. And I will replace all the instances of box with sum. Oh, I forgot to rename that. Let me run my tests. Oh, box is not defined. Perfect, tests are passing. And then let's say option here. And we'll run our tests. Oh, perfect, passing. And then I'm going to introduce something that will be helpful for you. So pay attention here. There will be an extra property called tag that will say a string sum. Oh, not failing here. Expected value to deeply equal. Yeah. To equal. Actually, I'm going to. Sorry, having a bit of a refactoring glitch. Sorry. Looks like I got caught by my own refactoring. So I will have to consult my notes. Oh. Oh yeah, thank you. So thank you, Carolina. Am I pronouncing it right? Close enough. So we're going to introduce this. We're going to introduce this sum function, and we're going to introduce another let's call it constructor, type constructor called none. Okay, so now I will switch to a different JSFiddle from my notes, and we'll get it on from there. Okay. So you can see that this is basically a very similar thing. We have the sum function, we have a none object, none instance, and then a very similar implementation of map, AP, and flat map. And then I'm going to be adding steps B. So step 0B is now that if you give none, then you expect to get none back. Basically, I'm comparing the same object with the same object, so that's easy enough. Now in step 1B, we're going to implement a similar we're going to call a method map, but instead of first argument being a sum, we're going to give it none, and then if I apply an increment function, I will expect to get none. So if you give me nothing, I'll give you nothing back. And this is failing now. So I will give you 4 minutes now to implement this step 1B test. And let me share the new JSFiddle with you. Again, reminding you, you can ping me on private chat if you need a hint or if you're struggling with something. you still have, you have 1.5 minutes more. If you're done, feel free to to send me a message that you're done as well. I will at least have a gauge of how many people are still going at it. And time's up. So let me show you the implementation. And there's many ways, again, there's many ways to do it. I will show you only one of them. So I will use a switch here. So what I will do is I will switch over a tag. So this is the most difficult step, by the way, step 1B. Now that I'm going to show you a bit of a pattern here, so hopefully the next steps are going to be easier. The pattern here is to use the tag to distinguish between which case are we working on. So basically, if my box has a sum inside, I will use the old implementation. But if there's nothing in it, there's nothing in my box, I will just return nothing. So sort of describes what I said as a sentence before. If you get nothing, you give nothing back. And then if I test it, it works fine. So you can use an if else here. You can use a lot of other ways. Switch statement, although clean code and people often say switch statements are not great and they're a bit of an anti-pattern. There's this thing called pattern matching. So you might want to look that up in the functional languages. And switch statements resemble the pattern matching the closest when it comes to the syntax. So they're quite helpful to model this. Okay, so let's get on cracking to the next step. Again, we're 30% through implementing our pragmatic application of a monad. So step 2B. We'll basically do similar as we did in step 2, but instead of having first argument being a sum, like it was here, we'll pass a none. And a function boxed in a sum. And again, if you give a none, you get a none. And just to clarify, you need to extend a p function. And let me send you a link to the new step. And the new code. And you have, let's say, 3 minutes for this. And you have 1.5 more minutes. All right, time's up. Let me implement this. And again, what I'll do is I'll add a switch statement here to switch on a tag. And then I will have 2 cases. Case sum, where I will copy my previous implementation. And I will have a case none, where I will just plain return none. And voila, test passes. So now we have or 60% through to implementing our monad. Now before I go to the last step, there's actually a bit of a shortcut I'm taking here. I won't cover and that's sort of, let's say it's your homework. I won't cover the case where the second argument is none. So that's also possible. So if you're curious, try it out after the workshop. It should be pretty easy for you to implement. I will at the end share what the test should look like. But for now, step 3B. And then again, if you give me none, I will give you none back. I got some solutions already. So let me give you 1 minute to to implement this one, and your code goes here. Yeah, this one should be relatively easy for you. We have 20 more seconds. Okay, time's up. And the implementation that everyone has been waiting for. Again, switch statement. In our case, sum. And we're gonna copy the implementation here, indent it nicely. And on none, again, you give me nothing, I give you nothing back. Ooh. There you go, done. Okay, so yeah, that's that. You basically implemented a monad in JavaScript, with a small caveat being the app function not being quite there yet. So let me just quickly give you the test that you might implement later on, which will actually, yeah. There you go, step 2C, and I will paste it on. So don't go on and implement it now. I'm going to continue to the presentation, but you can have a shot at that. Have a shot at that later. Okay, so yep, you just implemented your first monad option called maybe. So option monad helps you represent similar concept to checking for whether something is undefined in procedural languages. The difference being that monads are sort of like design patterns. They're the patterns to structure your code. So whereas in non-functional procedural language, you would just do a check every time you have a method to see if something is undefined. And functional languages, and I'm introducing a bit of a magical question called fold here, but just to show you an equivalent, you would instead have that method represented as an option. And as you implement it yourself, you would map over it, which means regardless, where there's nothing, you just nothing. Where there's something, you apply the function, and then depending on the context, you either send it to the database or you log it to the error output. So another way to think about it is monads basically, the check for undefined is sort of embedded, so you can't make mistakes. You can't forget to write if x equals undefined, because every time you try to interact with a monad, you have to basically interact in a way as if something was non-existent. So I think it was Hoare or Dijkstra who said that introducing nulls and undefineds was $1 billion mistake, and monads sort of allow you to help with that. Other popular monads, array, list, either, task, async, reader, writer, state. This is a surprise, isn't it? Array and list. Array can actually be a monad. And you've seen map method for arrays. And I got this question from one friend before. Is map similar to monadic map? It's exactly that. A map on an array is the same map. Flat map on an array is the same flat map. So in the same way, options help you deal with undefined. Either will help you deal with errors. Tasks are also called asyncs, help you deal with promises. And there's other monads which are outside of the scope of this workshop for sure, but you can read up on them yourself. So something to start you off for next steps. There's a lot of JavaScript implementations. I recommend to this amazing documentation, and also they have amazing source code. So I learned a lot from reading source code, and don't be shy reading the source code. I mean, you just wrote your own monad, and don't be shy of reading the source code and learning from there. If you're not using monad, it's going to for sure expand your knowledge regardless. Thank you. That's pretty much it. That's the scope of the workshop. It's basically, I want to give now some space to you to let me know, what else is still puzzling you, what kind of questions and comments you have. Please share them on the main chat to everyone, and I'll try to answer. Okay, looks like there's not really any questions this time. Great. Thanks very much for your time. I will be sharing this. I will be sharing this. This website with everyone. Feel free to use it in your company. Feel free to use it with other people. You have the JSFiddles, you have the templates, you'll have the presentation, you have everything you need. My agenda here is to basically make sure that people are not scared of monads. If you don't use monads, don't use them because you understand them, rather than don't use them because you're scared of them. Thank you so much for spending time with me in the workshop.
Thanks, Pawel. Really enjoyed that. And yeah, everyone, this session has been recorded, so we'll get it uploaded onto YouTube as soon as possible and sent and shared round. If anyone else is interested in getting involved, hosting a workshop, giving a talk, anything like that, either you yourself or someone at your company, please do reach out. But for now, that's all from us. So thank you very much. And yeah, we'll take care. Speak to you later. Bye.